Okay, here we go. So what we are going to do today is we are going to use the synthetic division that we learned in the previous section to solve some equations that we couldn't solve by factoring. Okay? So for example, if I threw this one at you, 2x cubed minus x squared plus 2x plus 5 equals 0, and you looked at that and you said, okay, I know that I set it equal to 0, and then I try and factor. But you would look at it and you would say, well, there's not an x in every term, so I can't factor any x's out. And the numbers are not all like even or multiples of 3 or anything like that, so I can't factor anything like that out. So previously, if you were faced with this problem, you would have to say, I don't know how to do it, okay? But now we've got the skills, okay? Because we have learned the super easy fun technique of synthetic division, and what I know is if I can figure out a number that I can put right here and do the synthetic division thing and get 0 as an answer right there, then I have found a solution to that equation, okay? So that's what we're going to do. And to start with, it's pretty much just a guess and check, okay? So you're just guessing numbers that could go into that box and figuring out if they would work. But math is going to give us a little bit of guidance, okay? So the numbers that we're going to try, the only numbers that will work, are numbers that are a factor of this divided by factors of that. All right? So what are the factors of 5? 1 and 5. What are the factors of 2? 1 and 2. Okay? Now, sadly, because this opens up a few more options and makes the guessing part a little bit difficult, not only is it just the factors, but they could also be positive or negative. Okay? And so what that means is, if I go plus or minus 1 divided by plus or minus 1, what do I get? Plus or minus 1. So plus or minus 1, those are a couple of things that I could try to put in the box. Or I could go plus or minus 1 divided by plus or minus 2, which would give me what? Plus or minus 0.5 or 1/2. Or I could go plus or minus 5 divided by plus or minus 1, so that would just be plus or minus 5. Good. Or finally, I could do plus or minus 5 divided by plus or minus 2, yeah, which would be plus or minus 2.5 or 5/2, okay? So what we end up with from this is 8 choices, one of which is going to work, okay? So who would like to make a guess? 5. All right, so Alexandria says 5. Now, when we're going through this process, and we're finding ones that don't work, it will help us to think a little bit about why, and that will make our next guesses be a little bit better. So I'm going to bring down the 2. 5 times 2 is 10. Negative 1 plus 10 is 9. 5 times 9 is 45. 2 plus 45 is 47. And then 5 times 47 is 235, which gives me 240, okay? Shh, 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 shh. Right, so that clearly does not work. That clearly does not work because I don't get anywhere near 0 as an answer, okay? So before we make another guess, let's think a little bit about why this failed. What do I need to have right here to get 0 as an answer? A negative 5. Okay? So what probably has to be true about this number? Yeah, for me to end up with a negative, I'm probably going to need to start with a negative, because what you probably notice is once I got to here, as soon as I hit this positive, this is going to be positive, this is going to be positive, and this is going to be positive. So I probably need to throw a negative in there to make those cancel out. Okay? So instead of trying 5, what do you guys want to try? You want to try negative 1? Okay, let's try negative 1. So, hey, Colby. This is not a social hour. This is not a restaurant or a bar. This is a classroom. Okay, behave as if you are in one, which means please be quiet and respectful of others, including the big guy in front. Okay, too much talking in here. Okay, negative 1, so I bring down the 2. Negative 1 times 2 is negative 2. Add those together and I get negative 3. Negative 3 times negative 1 is positive 3. Add those together and I get 5. Negative 1 times 5 is negative 5. Add those together and I get 0. Nice job, Abby. Okay? No. Thank you. Dojo point for her. Yo. No. I'm going to handle it. Is it about this? Okay. Go ahead. Shh. That is a great, great question, which will definitely earn you a dojo point. Zoe says, what if you do all the numbers and none of them give you 0? Okay. That means your answer is no rational roots. Okay? All right? That's important because that's going to happen. Okay? So Peyton, I want to make sure you heard that. What was her question? Yeah, you have no idea. Okay, her question was, I will repeat again, Alexandria, this is for your benefit also. What happens if we plugged in all of those and none of them work? Then your answer would be, it's not no solution, because what we're trying to do is we're trying to find the rational roots. It'd be no rational roots. Okay? There could be some irrational ones, there could be some imaginary ones, but there are no rational roots. Okay? So this works out to be x equals negative 1. Okay? All right, so let's keep going. Now the fun thing is that once we have this broken down the first time, I don't have to go all the way back to the beginning to try again. Now I can start with what's called the reduced polynomial and just check this. Okay? So we did negative 1. Negative 1 was a winner. We tried 5. 5 was a loser. What do you want to do now? Negative 1/2. So that's going to be negative 1, negative 4. That's going to be 2. So this is an easier one to do now because I only have 3 numbers. Okay? And that one's not going to give me 0, so that one's out. Yes? Because there could be more. It says find the rational roots. Okay? Well, there is an easier way. Would you like to know the easier way? Okay. Once we have found the first one, then we can use the quadratic formula from here. Okay? And this is A, this is B, and this is C. Okay? So to use the quadratic formula, I have to take the opposite of B. So the opposite of negative 3 is 3. Plus or minus the square root of b squared. Negative 3 squared is 9. minus 4 times a times c. Then you take that total and divide it by 2a. 2 times 2 is 4. Okay? So then that's 3 plus or minus. What does this work out to be? What's 4 times 2 times 5? 40. What's 9 minus 40? Yep, negative 31. And then I don't know the square root of negative 31, so really all I can do with that is take out the I, and then I'm done. So, Callista, were you the one that said, do we have to do this all over again? Yeah. Okay, thank you for asking that, because hopefully you can see this answer right here is not any of these answers right here, so none of these were going to work. So Callista saved us a tremendous amount of time. Okay, what's that? Okay, Sydney also asked a good question. Could we not have just done that from the beginning? And sadly, the answer to that is no, because this is a cubic, and the only formula that we have is the quadratic formula, not the cubic formula. There is such a thing as the cubic formula, but it's more complicated than it's even worth. Okay? Yeah, then you can always use the quadratic formula. Yes, Peyton? No, now we're done. Okay, so we know the answer is x equals negative 1 and x equals 3 plus or minus I root 31 over 4. Yeah. Oh, right, in this case. Yeah, right. Technically, no, because this question is asking for the rational roots, and this is imaginary and irrational, so that doesn't count as a rational root. So the only answer that they really want is x equals negative 1. But we kind of had to do this to figure out that that is the only answer. Because if this had worked out to be 3 plus or minus the square root of like 4 over 4, that would come out to be a rational number. So then, yeah. Yeah. Okay, so here's my first question to see if you understand and have been paying attention. If I start this time with 3x cubed plus 7x squared plus 6x minus 8, how do I find the possible answers that I'm going to plug in? Callista? Okay. Okay, and the 8 goes on top, which is confusing because it comes afterwards, and the 3 goes on the bottom. So what are the factors of 8? Good. So I'm going to go plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. What are the factors of 3? Just 3 and 1. Okay, so this one is a little bit of a bummer because it has more factors. 8 has 4 factors where 5 only had 2. So this time we have considerably more choices. Okay. Yes, this is an advanced math class. So what do you want to try first? 1? Yeah, if you wanted to list them all out. But this time there would be 8. Do you want to list them all out? Okay, it'd be plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus, too late, can't stop me now, 4, plus or minus 4/3, and plus or minus 8, plus or minus 8/3. Okay? The factors of this number divided by the factors of this number. Okay? Okay, so somebody said 1. What do you want to try? Yeah, 1. Just go with an easy one. So if I do 1, 1 times 3 is 3. That gives me 10. That gives me 10. That gives me 16. That gives me 16. And that gives me 8. Okay, so 1 is a loser. Okay. Again, we want to be thinking about this process and seeing if we can use that to make a better guess. Okay, 2/3. 2/3 of 3 is 2. 7 and 2 makes 9. 2/3 of 9 is 6. 6 and 6 makes 12. 2/3 of 12 is 8. No, it works. Winner. Okay, so one answer is x equals 2/3. Nicely done. So hopefully what Zoe did is when we went through here the first time, she might have noticed that these numbers kept getting bigger. And so that was kind of a clue that we needed a fraction to knock those down a little bit, okay? All right, then once we have this, like I said before, we don't have to go through this all again. Callista saved us that trouble. We can use the quadratic formula to see if there's any other rational roots. Before we do that, though, what do you notice about these three numbers? They're all factors of 3, so I'm going to divide them by 3 and go 1, 3, and 4. Okay, so now x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2. What? I divided all those by 3 because it made it easier. Yes? Sure. When we're done with this, let me, I'll try and write down a step by step. Okay? All right. This works out to be -3 plus or minus the square root of -7 over 2, which is not a rational number. So that means we don't really need that as our answer, but we're being thorough. Yeah, I think I owe you a couple of them, don't I? Because you, yeah, for that good question, and also you figured out 2/3. That's a 7, yeah. Yeah. Thing in here then that you need to know is super easy, so please pay attention to this because it's pretty easy to figure out. It'd be a shame for you not to get this part, and that is that if you are solving an equation ever in your entire life, Peyton, and one of your answers comes out to be the square root of 2, there's gonna be another answer for sure also, and that is negative square root of 2. Because you know how when you do square roots you do plus and minus, okay? So if square root of 2 is one answer, then you know negative square root of 2 is the other one, okay? Now what's slightly tricky about that, Gavin, you're so sly. I didn't see you take that phone out of your pocket and then glance down there. Never knew what was going on. Trying to change your music. Yeah, bad song. Yeah. Okay, then if you have 1 plus I, you need to remember, Brennan and Callista, that I is the square root of -1, right? So if you have 1 plus I, then you will also have 1 minus I, okay? So that's what this slide back here is talking about. is that anytime you have a positive square root, you will have a negative square root that goes along with that, okay? And so it's disappointing that Colby and Luke are just choosing to just continue to have a conversation like every day in this class is a sleepover, because that's going to be such easy points for you, and you totally missed it. Jessica? Yes. Yes. Right. Yes. Oh, it's not equal to it. No, all I'm saying is if you get I as an answer, then you get negative I as an answer also. You know that. Right. The only thing you change is the I. The only thing you change is the square root part. Yeah. Yeah. Okay. Okay. So, if I know that 3 minus 2i and I know that 5 halves are answers, what is one additional root? 3 plus 2i, okay? And as Brianna and I were just talking about, and you guys should have been listening because all these questions are good, you don't change the 3 to a negative 3, you only change the part with the I in it, okay? So 3 minus 2i gives you 3 plus 2i for free. Does 5 over 2 include negative 5 over 2 also? Okay. No, because this is not a square root. Okay? So you only get the plus and the minus when you're dealing with square roots. All right? All right. So you can use this then to, and we've done this already, but if I tell you that the roots that we know are x equals negative 4 and 2i, and I want you to write out the polynomial, then since you know negative 4 is a root, what's one of the things that goes in parentheses? Good. X plus 4. If you know that 2i is one of the roots, then what goes in the next parentheses? X minus 2i. But, right, if we know that 2i is a root, then we know that negative 2i is a root also. So that means another thing that could go into here is x plus 2i, okay? Yeah, that's it, okay? All right? Because when you, the reason why this works out this way is because if you have x squared equals 9, how do you solve that? Square root both sides, so that gives you x equals, whoops, the square root of 9. Okay, but the square root of 9 can be 3 because 3 times 3 is 9, or it can be negative 3. Anytime you do a square root, you get 2 of them, right? But that's not the case if you just solve like a simple equation like this. If I have 2x plus 8 equals 0, how do I solve that? So that gives me just x equals negative 4, but it's not like negative 8 divided by 2 is also positive 4. It's only negative 4, okay? So these answers come from adding or subtracting, multiplying, and dividing, so there's only one. But these answers come from square rooting, and that gives you 2, okay? All right. Do 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 do. Oops.